Hello everyone, Mr. Fawcett here, and we're back with another geometry lesson. Today we're going to continue our discussion of perpendicular lines. We're also going to talk about the difference between parallel versus perpendicular and take a more algebraic approach today. So this will be more similar to what you may have studied in Algebra 1. A lot of it may be review, again, depending on how in-depth you went into this content with your Algebra 1 teacher. Before we get started, you have four questions, 1 through 4. All you're doing is simplifying. So basically, these may look like slope equations because m usually represents slope. So just practice simplifying those fractions and then we will get going. All right, so let's take a look at number 1. 7 minus 5 gives us 2. 8 minus 3 gives us 5. No more simplifying can be done, so 2/5. Number 2, negative 3 minus 6 gives us negative 9. 5 minus negative 1 is like 5 plus 1, so we get 6. This can be simplified. We can factor out a 3 from both the 9 and the 6, so we get negative 3 over 2, or negative 3 halves. Number 3, 4 minus negative 4, again, is like 4 plus 4, so it gives us 8. And 2 minus 2 is 0. This is undefined. We cannot divide by 0. So this fraction is undefined. Again, 8 divided by 0 is not 0. Again, that may be a common misconception students may have. If you divide 0 by 8, then it would be 0. But dividing by 0 leads to something undefined. All right, last one. We get negative 3 plus 3, which is 0. 1 minus 6, which is negative 5. In this case, 0 divided by anything other than 0 gives us 0. So just some practice simplifying some fractions. Again, this is going to lead us into something or things for today because we're going to be working with slope a lot today. All right, let's take a look at this graph. Feel free to read questions 1 and 2 and try to answer them based on the graph. All right, so we have a graph. We're looking at runners A and B. They're both running a certain distance, and it shows us their time along the x-axis. So question number 1 says, who ran the farthest? How do you know? Well, if we look at the red and the green line, or segments rather here, we're going to take a look at the y-axis. They both start at 10 kilometers, and they both finish at 0 kilometers. Again, we're just looking at the y-axis here. That represents distance. So they ran the same distance. Maybe they were both in a 10-kilometer road race. Now, who ran the fastest? How do you know? So the runner A, the segment in red, his time stops at 30 minutes. So it took him 30 minutes to run a 10K, which is actually quite fast. And it took runner B 45 minutes. So runner A ran fastest because it took him 30 minutes compared to runner B's 45. The reason we did these two questions is because reading graphs is also something we're going to look at today, also an important skill when you're talking about slope. Okay, so look at the question below. It says, think about it. In your own words, describe what is meant by the slope of a line. So when you hear slope, many things may pop into your head. Just take a second to jot some of those things down and then come back and listen to our discussion. All right, so some things that may jump into your head when you hear the word slope are rise over run, or change in x over change in y, or steepness of a line. Other things also may come into play. You may think of m, because m represents slope in several of our equations, y equals mx plus b, right? Just for example. So there's many different things that you may think of when you hear the word slope. We're going to now try to focus on the most important. So the slope of a line is the ratio of the change in y values to the change in x values. So it is the ratio of the change in y values to the change in x values. Again, a ratio can signify division. So the ratio of the change in y values to the change in x values. So we have that quotient or that fraction right here. This represents slope. The change in x values is the difference between the x values of 2 points on a line, and the change in y values is the difference between the y values of 2 points on the line. So we could actually rewrite this into something that you probably certainly have seen, where we have y2 minus y1, y2 minus y1 all over x2 minus x1. Maybe you haven't seen the change in y. Change is denoted by a triangle in math, or we sometimes call it delta. So we can say delta y over delta x, or change in y over change in x. You may have not seen that before, but you have probably seen the y2 minus y1 all over x2 minus x1. So again, those are two ways of writing slope. So let's go down to the next page and get some practice actually finding slopes. So we just talked about this. Slope is equal to change in y over change in x, which is equal to y2 minus y1 all over x2 minus x1. Now, they do show rise and run in this diagram. And while rise and run is commonly taught, I don't think it's the best way to talk about what slope means, right? It's an informal way. When we talk about rise, they're just talking about, how far up on the graph you're going with your y values. And run, they're talking about going left or right along the x-axis. However, this can sometimes be confusing. Students can sometimes make mistakes. I think it works well when you're tracing a slope with your finger, but when you're just taking points and finding the slope, sometimes you're not given a graph. Rise over run doesn't necessarily tell you what to do, right? It doesn't give you an exact formula. It's more so something to help you when you're first learning slope. To either go up with your finger and over, or down and over, but it doesn't really tell you the formula to use to find slope. So we're going to stay away from rise over run. Again, I think it's a tool that you can use, but I don't think it should take the place of change in y over change in x. So here, instead of saying rise, we can just say change in y is equal to 6. And instead of saying run over here, well, we can just say change in x is equal to 4. Again, change in y over change in x is going to be more beneficial when you're really working with the slope equation rather than just trying to trace the slope on the graph with your finger. Because a lot of times you're not going to be able to do that. The axes are going to be way too large. They're not going to be marked off by single units. So that method is going to become more and more ineffective as you go higher and higher with your math learning. Let's look at 3 examples down below. And I'd encourage you to pause the video and work towards finding the slopes. Again, I am not going to accept tracing with your finger here. I want to see the actual slope formula be put in place. So that means you're going to have to label the points and actually use the formula y2 minus y1 all over x2 minus x1. Once you've done that for all 3 of these, think about what those slopes mean, and then you can join our discussion. All right, so for number 1, we have change in y over change in x. My 2 y values are 5 and 3, so 5 minus 3, and then I get 7 minus 2 This gives me a slope of 2/5. So slope of that line is positive. Again, that makes sense because we're going up and to the right. For number 2, we do change in y over change in x again, and we get 5 minus -3 all over 4 minus 4. This gives me 8 over 0, which we know is undefined. And this is what you will get for every vertical line. The slope of a vertical line is always undefined. Looking at number 3, we have change in y over change in x again. Again, I'm just writing it down to reinforce the thinking. Two y values are 4 and 4, so I get 4 minus 4 all over 6 minus 3. That gives me 0 over 3, which gives me a slope of 0, which is the slope of every single horizontal line. Okay, so just some basic finding slopes. I know this is nothing new to you, but this is something you're going to use in every single math class, all the way from here until you get to calculus, if you end up taking that in high school. So it shows up in every class. It's important. It is one of the foundational things of your high school mathematics curriculum. Let's move on, though. Oh, we have one more. We missed that. Take 30 seconds and do that now. I forgot that we had this at the bottom of the page. All right, so our 2 points here are 6 and 2 for G, and H is 2, 6. So my change in y over change in x, let's make that a little better, y, is equal to 6 minus 2 all over the quantity 2 minus 6, which gives me 4 divided by -4, which gives me -1. So again, our line is going down and to the right, so that is going to be a negative slope. One thing I guess we can talk about, just to make sure we're not having any misconceptions, think about whether this is true. So we've been saying change in y over change in x is equal to y2 minus y1. Think about whether this is accurate. And while you're at it, think about whether this is true. So the question basically is, can you switch the coordinates around and still get the same answer? So with the red example, as long as you switch both sets of coordinates, that's perfectly okay. It'll work. If we do it a little example, if we came down here, we could do 2 minus 6 all over 6 minus 2. That gives me -4 over 4, which gives me -1. So as long as I switch both coordinates, I'm okay. If I only switch one pair of coordinates, that is a no-go. That will not give me the correct slope. My sign will be incorrect. And you could test that theory here. If I did 6 minus 2 all over 6 minus 2, this will give me 4 over 4, which is a positive slope. So again, this is no good. You can switch the coordinates as long as you switch both of them. You just can't switch one. Let's keep going. All right, so just the 4 types of slopes you can get. You can have a positive, negative, you can have a slope of 0, or an undefined slope. So now I think we're ready to jump into parallel and perpendicular lines, and specifically how the slopes of these lines come into play. So you have parallel lines, you have perpendicular lines, and you have 2 boxes below, the same and different. So think about what's the same between the 2 lines, and again, you're just comparing the parallel lines to each other, and then you're going to separately compare the perpendicular lines to each other, and then go ahead and fill in those boxes. Okay, so for the parallel lines, a couple things we may notice. If we found the slope of both of those lines, we would see that the slope is the same. Okay, so the slope for parallel lines ends up being the same slope. You could come up with several differences. One of the key differences that we're going to focus on is y-intercepts. The y-intercepts of parallel lines are always going to be different. If they had the same y-intercept, well, you could think about if we moved this y-intercept to be the same as that one, well, then they would be the same line, right? Because every single point would be moved up 3 in this case, and this line would just end up being directly on top of the other one. So parallel lines, if they are two distinct lines, will have different y-intercepts but the same slope. Perpendicular lines, well, there's not too much the same about them, right? It doesn't really seem like they have many things in common, except they both share one point. So both lines share a single point. In this case, it's a point 4, -1, but obviously it wouldn't have to be that point if we move these lines around. There's a lot of differences, so the one that we're going to focus on is different slopes. We'll talk a little bit later about specifically what's different about those slopes, because there is a relationship between 1/2 and -2. But again, we'll focus on that a little bit later. So key thing to realize for parallel lines is that they have the same slope, different y-intercepts. For perpendicular lines, their slopes are going to be different, and we're going to talk right below about how they are different. All right, so let's look down below. And we have the parallel lines theorem. So in a coordinate plane, two lines are parallel if they have the same slope and different y-intercepts. That's just what we talked about above. The perpendicular lines theorem. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. And then it also says vertical and horizontal lines are perpendicular. Now, we have to throw this little caveat in at the end because the slope of a vertical line is undefined and the slope of a horizontal line is 0. So if you multiply those together, you're not going to get -1. However, a vertical and a horizontal line are perpendicular, right? They're still going to, vertical line and a horizontal line are still going to form a right angle. So the product of their slopes is not -1, but they are still going to be perpendicular, so that's why they throw that into the end. This is probably not how you learn to tell apart perpendicular lines from other lines. You probably learned about it using this next method. And that is, another way to understand this is that two lines are perpendicular if their slopes are opposite reciprocals of each other. And I think we've probably heard that word before, those words, whether we remember what that means. Opposite reciprocals. What am I doing? There we go. So what this means is that if we look here, their slopes are going to be flipped. So the numerator becomes a denominator, the denominator becomes a numerator, and you change the sign. The opposite part means change the sign. The reciprocal part means flip the fraction. So if we come over to the second example, 3/2, the opposite reciprocal of 3/2 would be -2/3. If you come over to this last example, it's a little different because we just have a whole number. But remember that you can rewrite -2 as -2/1. And then if you flip 2/1, you get 1/2. And if you take the opposite sign of a negative sign, you're going to get a positive sign. So that becomes +1/2. All right, let's see how many application problems we have and whether or not we want to make this part 2. No, we'll actually just make this a 1-part video to be a little bit long, but better than making 2 parts. Okay, so it says for these 3, determine whether the following sets of lines are parallel, perpendicular, and either. Now, it's important not to just look at the diagram. It's important to actually compare the slopes. So you're going to need to find the points. You're going to need to run the slope formula and then decide whether that means the lines are parallel or whether it means they're perpendicular, or maybe they're just neither. So pause the video, take some time to do that, and then come back and check out the solutions. All right, so I just put the work up there so you can pause the video and check it. Again, there's different ways you can set up your change in y over change in x equations, as long as you have both sets of coordinates flipped. We're now going to go down and do some algebraic problems without any graphs, and then that's going to be a video. So here they give us the equations of the lines. Some are in slope-intercept, some are in standard form. Doesn't look like we have any in point-slope form. I guess we'll talk about that next lesson. So you just need to find the slopes of both lines and again do the same thing. Compare them. Are they the same for parallel? Are they opposite reciprocals for perpendicular? Or are they neither? And that's our conclusion, is that they're neither parallel nor perpendicular. Notice that for some of these equations you may need to put it in slope-intercept form before you locate the slopes. So pause the video, take some time, and then we will go through one or two of these. Okay, so let's go through the first one. That's fairly straightforward. Our slopes are both 2 because these are both already in slope-intercept form, so these have to be parallel. For number 2, we have a slope. For the first equation, that is 3. Our second equation is not in slope-intercept form yet, so we've got to rearrange it. I'm going to subtract 2x from both sides, so I get 6y equals negative 2x plus 10. I'm going to divide by 6 to each term to get the y by itself, and I get y is equal to negative 2 divided by 6 is negative 1/3, x plus 5/3. So here our slope is negative 1/3, and negative 1/3 and positive 3 are opposite reciprocals, so these two lines are perpendicular. And, why not? Let's finish the last problem as well. For this problem, we have to actually maneuver both equations into slope-intercept form. So let's do the one up here first. 3x plus 2y equals 7. I'm going to subtract 3x from both sides. I'm going to divide by 2. Again, make sure you're dividing each term by 2. So I get y is equal to negative 3/2 x plus 7/2. Which means our slope is negative 3/2. Let's do the other one. The other one's a little bit easier. I just have to divide each term by 3. So I get y is equal to 4/3 x plus 7/3, meaning my slope is 4/3. However, 4/3 and negative 3/2 are not opposite reciprocals, so these lines ends up being neither parallel nor perpendicular. Okay, there are no more problems for you to complete for this lesson. You can certainly work in your practice packet though, and I will look forward to seeing you next lesson. We will continue with our discussion of parallel and perpendicular lines.